Okay, on Friday we looked at 3 different ways to multiply polynomials. We used algebra tiles as one way, the box method as our second way, and the distributive property as a third way. Only one person in all of my classes preferred the algebra tiles as a way to model, simply because it is so time consuming and you have to draw out the tiles as showing your work. So if this is the way that you prefer to do that, remember you're going to create your little T-chart here, and along the left side you're going to put one of your binomials. So the x plus 1 is the x and the 1 here. And then your other binomial on the other part. So 2x minus 3 is 2 x's and 3 negative 1's. And it doesn't matter which goes where. You could have put these along the left and these along the top. It would have been fine. And then you're going to fill in the inside with the length times width in each space. So x times x is where that x squared came from. And then we had another x times x. Here where we were multiplying the x by the negative 1, so we got a negative x, and an x times a negative 1 is another negative x, and then we did that again here. The next row, we're multiplying by 1, so 1 times x is x, 1 times x is another x, and then we had 1 times negative 1, which gave us those negative 1's right here. And so this represents the answer to the multiplication. We had 2x squares. To get the x term, remember every time you have a negative x and a positive x that you're adding together, they cancel out, just like 3 and negative 3. When you add those, they equal 0. Opposites always cancel. So these two positives cancel with these two negatives. So this cancels with that, this cancels with that. And so what we're left with is just 1 negative x in our answer. And then we have 3 negatives, which is a negative 3. So that's the answer to multiplying these binomials using algebra tiles. If you're using the box method, it's similar to the algebra tiles in the fact that you need to put one binomial along the left side and one along the top. And since you have 2 terms in each one of those, you need to make a 2 by 2 box. So you want 2 columns and you want 2 rows. So 1 term per spot, okay? And then you put the multiplication of those 2 terms in each box. So 2x squared we got for multiplying 2x times x. Remember, when you multiply an x by an x, you have to add their understood exponents of 1, and that's where that exponent of 2 comes from. Here you're multiplying 2x by 1 and getting 2x. Negative 3 times x is negative 3x, and negative 3 times 1 is negative 3. Then you always look for like terms. So these two both have an x, so I can combine those together. Negative 3 plus 2 is a negative 1. So that's where that negative 1x term comes from in my answer. So my answer is the 2x squared, the negative x, and the negative 3. It's the exact same answer we got with the algebra tiles. It's just using a different method. These are just your examples from Friday that I'm just going over here. And then the last method is the distributive property. Remember, the distributive property in multiplying a binomial by a binomial requires you to get 4 terms because you have 2 terms times 2 terms. 2 times 2 is 4. And so I've numbered all 4 multiplications you need to do. You need to multiply the 2x by the x and by the 1. And then you need to multiply the negative 3 by the x and by the 1. Just like the box method, you're doing the same multiplications and getting the same results. 2x times x is 2x squared, 2x times 1 is 2x, negative 3 times x is negative 3x, and negative 3 times 1 is negative 3. You still must look for those like terms to combine together to get your final answer, which is again exactly the same as the other 2 methods. So we just want to look at a couple of more examples of multiplying polynomials. The first one, remember, this is just called a monomial because there's only one term. There are no addition or subtraction symbols separating terms. This inside the parentheses is what we call a trinomial. The subtraction sign here and the addition sign here separates my 3 terms, which are 3x squared, negative 4x, remember that sign goes with that term, and positive 2. So if you want to use the distributive property, you're going to multiply this 2x squared by all 3 terms. One term by 3 terms. 1 times 3 tells you you have 3 multiplications to do. So if I'm multiplying 2x squared by 3x squared, remember the big numbers in front, which we call coefficients, just get multiplied together. 2 times 3 is 6. It's the exponents that get added. 2 plus 2 is 4. So my exponent on the x is a 4. If you're multiplying the 2x squared by negative 4x, you're multiplying the big numbers. 2 times negative 4 is negative 8. And adding the exponents. 2 plus an understood 1 means my x has an exponent of 3. And then the 2x squared times 2, the big numbers 2 times 2 make a positive 4, so make sure you put that plus in front of the 4. And then the x squared doesn't have an x to add exponents to, so it remains x squared. There are the 3 terms I expected to get when I multiplied using the distributive property. Are any of these like terms? No, because the variable part has to be exactly the same. So there are no other x to the fourths in my answer to add to this one. And there are no other x to the thirds, and there are no other x to the seconds. All of these are unlike terms. They cannot be combined. So that is my final answer. If you want to use the box method, you would need a 1 by 3 box. So that would either look like this, or it would look like this. And so you would put your monomial either here or here, whichever way you're doing it, and the trinomial would go along the other side. I would certainly think that the distributive property would be easiest here. The box method is not very necessary in this case. But again, you're just multiplying these together to get here. So that's where your 6x to the 4th would go. Multiplying these together, that's the negative 8x to the 3rd. Multiplying these, that's the 4x squared. These are just special case of multiplying binomials that I want us to look at. And so if you're using the distributive property, which is really the most efficient way for most students, a lot of students like to do the box method, however. So if you want to, just go ahead and set up your 2 by 2 box, since you have 2 terms times 2 terms, and put the x and positive 7 on one side and the x and the negative 7 on the other side. And then fill these in with those multiplications. If you're doing the distributive property, you're going to multiply the x by the x, and don't forget to add those exponents of an understood 1. So that would be x to the 2nd power when we multiply x times x. Your coefficient is still 1, because that's a 1 and that's a 1, and 1 times 1 is still 1. Then we're going to multiply the x by the negative 7, so we get a negative 7x. So we distributed the x, now we need to distribute the 7. So we're going to multiply the 7 by the x, and we get a positive 7x. And then we multiply the 7 by the negative 7, and we get a negative 49, because a positive times a negative is negative. Don't forget, if you're doing the box method, you're going to get those same 4 terms as you did with the distributive property. You always want to look and see if you have any like terms that you can combine, which we can. We have 2 that have just an x, and it doesn't matter which method you're using, you shouldn't recognize those. But you should notice something special about these like terms. These are opposites. If you add a negative 7x to a positive 7x, that means you have 0 x's. So do you write that in your answer? No, you do not. If you have 0 x's, that means you have no x's. So your answer ends up only being 2 terms, the x squared and the negative 49. So that's x squared minus 49 as my answer. So typically when we multiply binomial by binomial, we end up with a trinomial answer. But this time we ended up with just a binomial answer because those like terms were opposites. Now, here is a problem that lots of students miss the answer because they think that if you have a binomial squared, all you have to do is square each one of those terms. And so they will mistakenly give me the answer as x to the 2nd power plus 9 to the 2nd power, which is 81. That is incorrect, so do not do that. Remember, when you square a number, it means to multiply it by itself. So x plus 9 squared means x plus 9 is being multiplied by itself, another x plus 9. So I hope you know now when you multiply two terms by two terms, you should be getting 4 terms as your process of your distributive property. So when I multiply the x times the x, that's where I get x squared, adding those exponents of 1. When I multiply the x by the 9, I get 9x. And then I need to distribute the 9. 9 times x is another 9x. And the 9 times 9 is 81. Then I can combine my like terms. And so I have the x squared. I have a total of 18 x's plus the 81. So do you see how that is different than just squaring each one of the terms? If you just square each one of the terms, you're missing that middle term in your answer. So it's really important every time you have a binomial squared that you write that as the binomial times itself and do all 4 multiplications. Now let's look at the next example. It says to use a modified box to find this product. And so when you draw your box, remember most of the time we've been doing 2 by 2s because we had a binomial by binomial. But here we have a trinomial by a trinomial. And so that means I want to have 3 columns and I want to have 3 rows. Instead of a 2 by 2, I have a 3 by 3. So do you see we're going to have to do 9 multiplications all together. So it doesn't matter which trinomial you put here, but I typically put my first one along the left side. So I'm going to put the x squared as my first term, the 5x as the second term, and the 4 as the third. And then the next trinomial will go along the top. We have 2x squared, an x, and that's a negative 2. Don't forget that negative sign. So for this answer right here, we're multiplying the x squared by the 2x squared. So remember, this has an understood coefficient of 1 that's being multiplied by that coefficient of 2, which gives me a 2. Don't forget to add these exponents, so that would be an x to the 4th power. Here we're multiplying x to the second times x to the first. It's an understood 1, so that would become x to the third when we add those exponents. Here we're multiplying x squared by a negative 2, which is negative 2x squared. Here we're multiplying 5x by 2x squared, so the 5 times 2 gives me a 10, and when we add those exponents, 1 plus 2 is an x to the third. Here we're multiplying 5x times x, so that 5 times that understood 1 still gives me a coefficient of 1. When I add those understood exponents of 1s together, that gives me an x to the second. 5x times negative 2, 5 times negative 2 is negative 10, and then we have that x. Here we have 4 times 2x squared, 4 times 2 is 8, and then we have that x squared. 4 times x is just 4x, and 4 times negative 2 is negative 8. So there's all 9 terms for the 3 by 3. You could also use the distributive property to distribute the x squared, then distribute the 5x, but then you would have to also distribute the 4. So there's what all 9 terms would come from in the distributive property. Remember, when you go to write your answer, go with the highest exponent first, 2x to the 4th, and there are not any other x to the 4th, so that would be my first term. Then I would do the x to the thirds. Do you see you have like terms here? You have 10x to the thirds plus another 1x to the third, so that's a total of 11x to the thirds. Then my x to the seconds, I have 3 of. So how many x to the seconds do I have? 8 plus 5 is 13, and then a negative 2 brings me down to 11x squares. Then my x's, I have 2 of those. 4 and negative 10 make negative 6x, and then I only have one constant, which is negative 8. So there is my final answer for the product of that trinomial times that trinomial. All right, so your assignment is to finish your worksheet from Friday, which was 16.1. You'll have the homework quiz over this tomorrow, but make sure you have your homework completed.